Hello, my name is Gemma Bonson, and the telescope I chose to do research on is the Fermi Gamma Ray Space Telescope. So, a little introduction. The Fermi Gamma Ray Telescope was launched into space on June 11, 2008, and still remains in orbit. It observes gamma rays from a low Earth orbit, and it was a joint venture of NASA, the United States Department of Energy, and several different agencies across the world. This telescope was named after physicist Enrico Fermi, and he is famous because he invented the first nuclear reactor. So, its objectives and tasks, there are many, but its main tasks are to study gamma ray bursts and solar flares, which gamma ray bursts are short but intense flashes of gamma radiation from deep space. Um, it is sent up in space to investigate active gamma nuclei, which are basically supermassive black holes at the centers of galaxies. It examines pulsars and neutron stars, which are like dense remnants of supernova explosions, and searches for dark matter. So this is matter that does not emit or interact with magnetic radiation, and it's detectable through gravitational effects. So it has many instruments on it. These instruments include a large area telescope. This is the main instrument used for detecting these gamma rays, and it detects photons with energies from about 20 million to about 300 million electron volts. It also has a gamma ray burst monitor, and this detects gamma ray bursts in that energy range across the whole sky, not occluded by the Earth. Um, and it works hand in hand with the Large Area Telescope by detecting lower energy gamma rays. So, its main discoveries that it's most famous for are the fact that it identified over 5,000 gamma ray sources since it's been sent into space. And it also discovered Fermi bubbles, which are named after it. And these are giant structures extending above and below the Milky Way center, which we had no idea existed before the launch of this telescope. It has many future endeavors that it hopes to accomplish. Some of these include to understand the mechanisms of particle acceleration in active galactic nuclei, pulsars, and supernova remnants. It also aims to resolve the gamma ray sky, unidentified sources, and diffuse emission. It aims to determine the high energy behavior of gamma ray bursts and transients, and hopes to probe dark matter by looking for an excess of gamma rays from the center of the Milky Way and the early universe. Overall, the Fermi Gamma Ray Space Telescope will continue to be a cornerstone of astrophysical research, with its data and discoveries impacting science for decades to come. I found this telescope very interesting and will hope to learn more about other telescopes and how they impact us. Thank you so much.